Alright, so we got this problem here. We want to know if it converges or diverges, and if it converges, then evaluate it. First thing we're going to do is to want to make sure, check to see if this is an improper integral, which it clearly is because it's got infinite bounds. So let's state that. Then, here, let's rewrite this as, first using the definition, 9 to t, and then we'll just move the x minus 8 to the numerator. Okay, this is using our definition of improper integral. And now we see we can just do u sub equals the limit as t approaches infinity. Oh wait, before I go back to the limit, let's see here. Let's plug in 9 into 8, x, and we'll get 1 on the bottom as the lower bound, 1 on the bottom, and then as t approaches infinity, if we put that into x, as t approaches infinity of t, if we put that into x, we'll get infinity minus 8, so that is still infinity in the top, and so we can just keep that there. And we get u to the negative 3/2 du, and this becomes the limit as t approaches infinity of negative 3/2 if we multiply by, or we add 1 first to the power, so that becomes negative 1/2, and divide by that, that's negative 2 times u to the negative 1/2, and evaluate from 1 to t. And then we got a limit as t approaches infinity of negative 2 over u, or square root of t, minus or plus 2, because the negatives cancel out, 2 over the square root of 1, which is equal to the limit, because this approaches 0, as t approaches, or we don't need that anymore. Erase this, is equal to, we'll just evaluate it now, as the limit approaches infinity of this, as the limit of t approaches, or as t approaches infinity of this, is just going to equal 2. And therefore, it implies that it's convergent.